Alright, and here's another one of the same kind of problems. We're going to follow the same steps. First thing that we're going to need is the slope formula. Okay, so again, we're going to use x1, y1, x2, y2. Okay, and we're going to find the slope. So we're going to take our y2, which is 2/3, minus our y1, which is 2. Put that over our x2, which is -5, minus our x1, which is 1/4. Alright, now this is with fractions, it's kind of messy. That's why I gave you this example. Okay, so 2/3 minus 2, well, that is -1 1/3, which is the same as -4/3, over -5 minus 1/4 is -5 1/4, which is -20 1/4. Now we can't possibly write a slope like this, so now we just got to know what fractions mean. Okay, so we got a fraction here, and we're dividing by another fraction. So we're going to have some flippin' fun. I'm going to take -4/3 divided by -20 1/4, which of course means I'm going to have flippin' fun. So I'm going to take -4/3 times the reciprocal, which is -4/21. Okay, you can tell this one gets kind of messy here. Alright, so my slope, a negative times a negative is a negative, and then I'm going to get m equals 4 times 4 is 16, and 21 times 3 is 63. So I get 16/63 for my m. Looks like a fun number, doesn't it? So now we got to use that. We're going to solve for b. So when I solve for b again, I'm going to use one of the points. Doesn't matter which one. Again, I like all positives, so I'm going to use this one. So step 1 was all right here. Find the slope. Now we got to do step 2, which means we're going to use our m of 16/63. And my point that I'm going to use is 1/4 and 2, my x and my y. I'm going to plug those into y equals mx plus b form. So I'm going to get my y, 2 equals 16/63 times 1/4, which is my x, plus b. Well, at least this one cancels a little bit. Here we're going to get 2 equals, and then 16 and 4 break down into 4 and 1. So 4 times 1 is 4, 63 times 1 is 63, plus b. So now I've got to take 4/63 away from 2. So I'm going to subtract 4/63. And if I do that, well, let's think about this. I'm taking 2 minus 4/63. So first thing I should figure out is how many 63rds are in 2. Okay, and that's going to be 126/63 minus 4/63, which is going to give me 122/63. Alright, that ends up being 1 and 59/63 if you want to break it down, but you don't have to. Alright, because that number is reduced. There's nothing that goes into 122 that also goes into 163. So that's my b. Okay? So step 3 is to take my m, 16/63, and my b I just found, 122/63, and plug them into the y equals mx plus b form. So I'm going to get y equals 16/63 times x plus 122/63. Look, that's a gross problem, but it's a good one to show you because sometimes that might happen. Okay, now key thing to pay attention to on this problem is this part way back up here. Okay, when we did the slope up here, you get a fraction on top of a fraction, that's okay. Just make sure you understand it's a division problem, and then figure out what the slope is by using flipping fun. Okay, and let's go on to one last example. Alright, so in this problem it says, for our science class, you need to know the Celsius equivalent of normal room temperature, 70 degrees Fahrenheit. To estimate the Celsius equivalent, you use the knowledge you previously acquired about Fahrenheit and Celsius temperatures of freezing and boiling points of water. Okay, so for example, the freezing point of water is 32 degrees Fahrenheit, which is the same as 0 degrees Celsius. The boiling point is 212 degrees Fahrenheit, which is the same as 100 degrees Celsius. So we want to estimate the Celsius equivalent of normal room temperature. Okay, so we're going to use y equals mx plus b form, or in this case, we're going to use, it's the same kind of thing, Celsius equals slope times Fahrenheit plus b. Okay, so we're going to use our 2 points that we figured out that go together. Okay, we've got freezing point and boiling point. So the freezing point can be written as an ordered pair, which is 32 degrees Fahrenheit and 0 degrees Celsius. Okay, and the reason why I put the Fahrenheit first as like the x value is because in this setup it's the x value, okay, where my Celsius is my y value. So we got the Fahrenheit in the x spot, the Celsius in the y spot. Well, then we've also got boiling. We can write an ordered pair from that, where Fahrenheit is 212 and Celsius is 100. Okay? Well, to fill in our equation in this format, we're going to use the same process that we've been using all day here, or all lesson, and we're going to use the slope formula. Okay, so we'll call this like our x1 and our y1 and our x2 and our y2. Okay, so we're going to plug in on top 100 minus 0 over the bottom is 212 minus 32. Okay, well 100 minus 0 is 100, obviously, and 212 minus 32 is 180. So that's going to break down. Eventually, we divide both those by 20, and we get 5 over 9 for our slope value. Okay, so our m equals 5/9. So there's step 1. Now step 2 is to use our slope and a point together. Okay, now in this case, to me it makes sense to use this one since it's got a 0 there, and zeros are usually pretty easy to work with. Okay, and these are lower numbers. So my we're going to have the point 32, 0 is the one I'm going to use here. And we're going to put this, we have Fahrenheit and Celsius, so we're going to put this in Celsius equals m times Fahrenheit plus b format. We need to solve for b. Well, our Celsius is 0, our slope is 5/9, times our Fahrenheit, which is 32, or 32 over 1, plus b. Alright, so we're going to get 0 equals, and this one's going to get kind of messy here, 5 times 32 is 160 over 9 plus b. And then we're going to subtract 160 over 9 from 0. And that's going to make our b value equal to negative 160 over 9. Okay? And then for step 3, we're just going to plug these into our setup here. Okay, so we're going to get our slope was 5/9, and our b was negative 160 over 9. So we're going to get Celsius equals 5/9 times Fahrenheit minus 160 over 9. Okay, so there's our equation. Then the question asks you to estimate the Celsius equivalent of normal room temperature. Well, they tell you up here that normal room temperature is 70 degrees. Alright, so I want you to go ahead and figure that out, and I will be checking for that answer before I check off your notes. Okay, so good luck, and good luck on your homework.